Hello and welcome to today's tutorial, that is advanced programming's multi-threading. What is multi-threading and what is threading itself? As you know, when we run a Python program, all the codes are run sequentially in the interpreter. But that's not a very efficient, when we look at from a broader perspective, that's not a very efficient way of doing things. Like as you know, our CPU are multi-threaded processors. Which of these core has at least two or more threads. So each thread is capable of running a single process at the same time. So it can be summarized that while you should be able to run multiple Python functions at the same time. And using that thinking process in our program itself is known as a multi-threading. Running thread is similar to running several different programs concurrently, but with the following benefit. Multi-threading within a process share the same data space and remain within the main thread, therefore share information or communicate with each other more easily rather than if they were separate processes. Threads sometimes are also for lightweight processes because they do not require much memory overhead. They are cheaper than processes. A thread has a beginning and execution sequence and a conclusion. It has an instruction pointer that keeps track of where within its context is currently running. It can be preempted, interrupted, it can temporarily be put on hold, also known as sleeping while other threads are running. This is called yielding. Starting a new thread. To spawn a new thread, you need to call the following method available in the thread module. Thread module. This method enables us fast and efficient way to create new threads in both Windows and Linux. Method call returns immediately the child thread starts and call function with the past list of arguments. When the function returns, the thread terminates. Arg is a tuple of argument. Use an empty tuple to call function without passing any argument. Quarks is an optional dictionary of key arguments. So let's take an example to understand how it works. So let's say first we'll import the thread modeler library to import and time library for knowing the time. Now we shall define a function for the thread, that is print time. It will be printing the time. Will be passing to it. Will be passing the thread name and the delay. Counter equal to 0. Count less than 5. We'll be running it. So let's get started. Now let's create two threads as follow. Which will be included with the thread 1 and thread 2. We'll be using a try except to catch if any error occurs. Let's run it. See, so the first thread was successfully created, second thread was created. Now again we have looking over, so we are getting more threads in concurrent session. So this is what you could see. Okay, so let's go back. Okay, the program goes on infinite loop. We have to be controls to stop. Although it's a very efficient way for low-level threading, thread module is very little compared to newer threading module. The threading module. The newer threading module in Python 2.4 is much more powerful, high-level support for threads than the thread module discussed in the previous section. Threading module exposes all the methods of thread module and provide additional methods like thread active count, return number of active threads that's written, thread current thread, returns the number of threaded objects in the folder control. Threading enumerate list of all the threads objects that are currently active. In addition to the method, thread module has thread class that implements threading. A method provides by the thread classes are run. It runs the entry point for a thread start. The starts and thread by calling the run method. Join time. Join awaits for thread to terminate. Is alive method checks whether a thread is still executing. Get name method returns the name of the thread. Set name sets the name of a thread. Getting new thread using threading module. To implement new threading module, we have to following define a new subclass of thread class, override init method to add additional argument, and override run method to implement thread start. Once you have created new thread subclass, you can create an instance of it. Start new thread by invoking start, which in turn calls the run method. Now let's take another example. Example 2. Yes, first we'll be importing threading library, which is the newer library as we have talked earlier. And let's just import the time module to get that time. Let's run it. Now let's define classes for threading. Then let's just have an exit flag which will be equal to 0. Let's have a class threading where we'll have self, thread ID, name and counter will be passing into the constructor. then threading the thread init let will be anything it. So it will set the thread ID as the passed argument thread ID, name as the name passed there, and counter as counter passed in. Now for running, let us define an internal function to run the thread, which will be starting, which will print starting plus self time, and we will have print time, which will print the counter time, and finally for to exit function to exit. Defining thread name and delay. Now, now let's have another function to print time, which we the function which we use basically in this line. So we have a thread name, delay, and counter, as you could see. Creating new thread. So let us create two new thread 1 and thread 2 here. Start new thread. Let us start the thread 1 and thread 2. Let's and then join them. Now, as you could see, we are going over, and so we have started already two thread, then the thread 1 printed this, thread 1 printed this, and thread 1 has exited, a thread 2 goes there, it's printed, and now the thread 2 exiting main thread. So this is how it takes place. Now let's go over the next section. Now synchronizing threads. The threading module introduces simple to implement locking mechanism that allows you to synchronize thread. A new block is created by calling lock method, which returns the new lock. A querying blocking method of the new lock object is used to force threads to run synchronously. The optional blocking of parameter enables you to control whether the thread is to equal the lock. If the blocking is set to 0, the returns immediately with a 0 value, and if the lock cannot be equaled with 1 if the lock is equal. If blocking is set to 1, thread blocks and wait for the lock to be released. The release method of the new lock object is used to release lock when it is no longer required. Now let's take the third example to illustrate the effect which is studied just now. Here we have a class name thread, which will be using to basically initialize that thread, and then we'll have a run to run that thread, and let us define a function print time, which will allow class time to print that time taken by the thread. Then now we'll be for synchronizing it, we'll be let us lock the thread using the thread lock method, and let's run it. And now let's create two thread 1 and thread 2. Let's start the thread. You can see we have already started that thread. We are printing the time for that thread, and we have both of them. Now let's add new thread to the thread list. Let's append thread 1 and thread 2 to the list. Now let's waiting for thread to complete. Okay, we have successfully exited the main thread. That's how it takes place. A multi-threading priority queue. The queue module allows you to create new queues and objects that can hold a specific number of items. There are following methods to control the queue. The get method removes and returns an item from the queue. The put method adds an item to the queue, and queue size returns the number of the items that are currently in the queue. Empty returns true if the queue is empty, otherwise false. The full method returns true if the queue is full, else false. Let's take the fourth example to illustrate this fact. So we'll be importing the queue method on top of the threading and time module. Let us create the classes. First, we'll have the myThread class where threading.thread will be using the threading.thread object, and we are similarly we are using constructor to initiate constructor to simply construct the object. Other than that, we'll have a run command which will be starting the final and exiting. Other than that, we will have a process. We will be calling the process data file. So which you could see here, the process data function have the thread name and queue, which is queue. So while not exiting reflect queue is equal. If not queue empty, then if the queue is not empty, then data will be equal to queue, and queue will be releasing the queue, and we will be processing and displaying the thread name and the data. Else we will release the queue and we will wait to sleep for a minute. So let's run it. And finally, let's just pass a thread list of thread 1, 2, 3 and a name list of 1, 2, 3, 4, 5 in the queue. And then let us lock the queue to basically synchronize the queues. Then and let us let us basically launch the queue, and let us make a list for the trace and trace ID. Let's go with that. It is done. Let us create some new thread. So we have started all the three threads, and let's fill the queue. So we have successfully processed process 2 and process 10, process 4, process 5. So it is done. Basically, let's put a queue to complete. This is done. Now let's notify the thread it's time to exit, and this is done successfully. Now let's wait for all the threads to complete, which is done successfully. So that's how we do it here, and that's finally it. We have finally come to the end of multi-threading in Python. Hope it was you were able to learn much from this. Thank you.